Morning. How's everybody doing? Day 3 of Ignite. You guys have some fun? See some good sessions so far? Yeah? A lot of people still waking up? It's okay. I'm the same. I'm seeing a lot of sessions. Being a Microsoft employee, it's actually a good chance for me to see what else is going on in the company, so it's a good chance to catch up on what some of the other divisions are doing. So we're going to talk about APS this morning. So how many of you actually know what APS is already? Fairly good group. How many of you have never heard of APS and somebody said, hey, you got to go listen to this thing? Okay. All right. How many of you have an existing data warehouse on premise? By the way, I'm a shoulder guy. I'm going to ask you lots of questions, so you might want to alternate shoulders. Okay. Throw some names at me. What do you guys use now? SQL Server, Vertica, Greenplum, Oracle, Teradata? Yeah, pretty common. Who has something that looks like a data warehouse over a terabyte? Pretty good. Keep your hand up if you got 10 terabytes. Ooh, all right, I see a good audience over here. How about 100 terabytes? Anybody got 100 terabytes? Oh, darn it, I was hoping. All right, so that's pretty common, actually. So APS is actually, and we'll jump into this a bit, but APS is really Microsoft's big data in a box. That's kind of like what we like to call it. So I'm going to walk you through what APS actually is, what it looks like, kind of some of the components of it, and kind of how it works. And I'll take some time at the end so you guys can ask me some questions, anything that I didn't cover. Feel free to come up and ask questions. I'll leave a little bit of time at the end. So I'm going to start this deck by kind of talking about the Microsoft Data Platform all up. So how many of you saw the SQL Server Foundation session? Quite a few of you? Okay, so this will sound a little bit of a repeat for you. For everybody else, really this is kind of Microsoft's approach to the data platform, kind of the entire stack. And I'll frame this as to how APS fits into the entire stack. And it's really built on these kind of 3 core kind of concepts, this capture and manage component, which is really kind of the storage mechanism. How do we store the data? How do we manage the data? This kind of transform and analyze kind of layer. So you think of things like machine learning and kind of aggregation models. And then finally, how do you visualize and decide on that? So things like Power BI. How does an end user Excel or SSRS? How do you actually use the data and make kind of insight decisions based on the data that you have? And it really looks like this kind of full up stack. And so when you think about kind of these different levels, there's different components that fall into this. So kind of on the bottom, you see those traditional kind of capture and manage. Here at Ignite, we've talked a lot about things like upcoming SQL Server 2016, Hadoop integrations that we have both on-premise and in the cloud. Things like NoSQL, DocDB kind of services that are actually working in the cloud. And then as we build up the layers, you can see that we work into things like Azure ML or kind of orchestration, event management, and then move into the top with things like Power BI and Excel, some of the dashboard things. If you saw DataZen, that's a new acquisition of Microsoft. Kind of those visualization, KPI dashboard type models. And it really gives you kind of an easy way to think about kind of these different layers. When we talk about APS specifically is at the bottom of this stack. It's really truly that capture, manage, and store data kind of model. So traditional kind of relational SQL database kind of model. And there's been a lot of talk about kind of cloud first. If you attended one of the sessions, I had one yesterday talking about SQL Data Warehouse, which is a new Azure service that we're launching later this summer. It's really kind of big data warehouse in the cloud. If you hear about kind of some of the other avenues of things that we're lighting up in the cloud, HD Insight, those kinds of things running in the cloud, you really kind of get these from an employee perspective. I get a lot of questions around, well, what's Microsoft doing about the box? Are you just abandoning the box? Are you abandoning the on-premise environment? Microsoft talks about this cloud-first, mobile-first world. And how does that translate to, hey, I still have hard requirements of having data on-premise. I still have hard requirements about, keeping data close, or I want the performance, or I want more control of what the environment is. And I have some requirement, whatever that may be, of having the data on-premise. And is Microsoft really abandoning that? And I'm here to dispel that. When we talk about cloud first, it means a couple of different things. From an organizational perspective, it truly means that we've changed our engineering principles and our design philosophy, and we flipped it 180 degrees. When we talk about something like APS, this is the same product team that builds the SQL Data Warehouse service, and so we talk about kind of the symmetry of the two. And Sean has used this example in the past of talking about how investing in SQL DB has actually transformed the SQL Server 26 product into a terrific product because we can do things at a speed that we were never able to do before. And I'll give you an example of that. When we talk about APS, we're able to transition services and components and features of the service that we'd like to build up into SQL DW. And when we do that, we'll be able to light it up for hundreds or thousands of instances running at massive scale across the world immediately. And we get the advantage of being able to get instant feedback on what's actually running in the cloud. Is it performant? Is it functioning well? Are people taking advantage of it? How can we make it a better product? And we get to iterate very, very quickly. And that speed of getting feedback and getting response and being able to make a decision from an engineering perspective means that as we introduce those features back into the box product, the product itself doesn't have to go through this iterative cycle. So if you've ever run like a CTP program with SQL Server, what ends up happening is Microsoft prints all these disks, we ship them out, we let you download them, you play with them for a while, we hope you give us some feedback, there's this kind of iterative loop, and that could take months. It literally can take months for us to get some valuable feedback. Whereas with the cloud, we can actually push things out and get feedback within hours. And we can hit hundreds of thousands of instances and get instant feedback. And it really, truly drives us into this kind of an agile model of being able to develop the system. So we get access to immediate feedback, we see if features are working, we can make improvements, and by the time the features ship in the box, all it is a point-in-time snap of actually a feature running. And we can continue to make investments from an engineering perspective on truly building systems that have been tested and tried and true and able to take advantage of kind of that instant agility feedback that we can get and then respond to immediately. And it also means that by the time something lands in a box product, it's been proven. Everybody's, and as a Microsoft employee, I'm somewhat ashamed that I always hear this, but whoever installs something the first time without waiting for a service pack, right? Very few people actually do that in their organization. When we talk about something like mission-critical data warehousing, that's generally something that people don't do. They're pretty conservative as just a general approach. And so they want to see that there's some proven component that this thing's actually going to work. I run my business on this, I depend on it, and if we make a mistake here, it can cost me hundreds or thousands or millions of dollars. And so I need to be sure that this is actually going to be something that I want to deploy, that it's safe and secure, and that it'll work. By being able to take advantage of some of the deployment capabilities that we have in Azure, things like SQL Data Warehouse, SQL Database itself, we're able to get that feedback immediately. And when we go land into a box product, we know that the system is true across multiple different types of iterations, whether that's different workloads, different data set sizes, different tooling that's interacted with the system. So we know that the system itself is proven. And so it gives a lot more confidence in the ability for us to trust the box products that we're shipping, something like APS. And finally, that kind of iterative feedback loop. This really ties back to the ability for people to look at a product, not only from our perspective, but from your perspective. You can start to interact with the product using the cloud service version of it, really understand how the feature's going to work, and as the feature lights up in the box, you're ready for that. You've given feedback to Microsoft, we've been able to respond, and you have a feature that you could take advantage of that's useful for you based on what it is that you're trying to do with the feature, not what some PM sitting in a cube somewhere thinks you're going to do. You've actually given us the feedback, tried it out, and played with it. And that iterative loop, right? We've all tried version 1s of products, and you go, it kind of works. Well, version 2's better, version 3 is really good. But imagine that you could do that in the course of a day or 2 days or 3 days instead of waiting 2 or 3 CTPs or 2 or 3 releases. You can do this in hours to days instead of weeks to months. And so it really gives a kind of a way for all this work that we're doing in the cloud to also transition back to the box. And it's really kind of a great story about how Microsoft is really improving our engineering to build better products. And so I wanted to start the talk kind of focusing on this is how we're engineering the system, but it's no means we're going to abandon things like box products or something like an APS. This is actually one of our core products, something that we care much about. So as we transition to talking about APS, we'll talk about kind of the traditional data warehouse. We think about kind of the things that in the past have been, what you would see from as a Big Five consultant, this was what I would come in and say, hey, look, this is how you're going to build a data warehouse. You're going to have all these sources, and you're going to just ETL the thing, and you're going to have this data warehouse sitting in the middle, and you're going to build some KPI dashboards sitting on the top, right? And consultants have made a lot of money doing this. The problem is in the last 15, 20 years, things have changed. No longer do we have kind of just these static data sources. We don't have the same data volumes that we've had in the past. You really see this kind of explosion of data coming into these systems. I mean, the fact that people are even talking about things in terms of petabytes and exabytes when we talk about massive scale in the clouds, that translates back to customers who have hundreds of gigs, terabytes. When we start to talk at these volumes and you think, wow, that's just an awful lot of data, and we're just getting started. As you think about all the systems that you can connect, whether that's your sales systems, your inventory systems, your web logs, all of these different places that are emitting data in your environments, it truly means that you're going to have this explosion of data happening. And with that, it becomes, kind of symptomatic of what people are now starting to do with these systems. The ability to respond in real time or near real time is starting to make certain businesses have some competitive advantage over their partners in their industry. So you think about companies that are able to take advantage of data almost immediately and how that impacts the way that they can do business. Imagine something like Twitter not being able to respond immediately to things that are happening in its environment. And you think, wow, how would Twitter succeed on something like not being able to say, oh, well, here's the people who are now following you. Here's the trends that are happening in Twitter, what people are talking about. I mean, those are big kind of components of the way that they think. And that's a big data problem. It's really traditionally, in a data warehouse, you would think, oh, that's not a data warehouse scenario. But you have other things that are happening. We have customers who use these systems to do security and fraud detection in their environments. They're pulling all of their weblog data, all of their router data, and shoving them into these systems and doing massive analytics across them to try to find out if their systems are just simply being broken into. And you think of all the places that have been broken into lately, all the announcements of credit card data and identity thefts and things happening. And these systems become critical that you have to do this in minutes, not hours, not days, not weeks, but minutes, and sometimes even seconds to be able to respond to these kinds of new world scenarios. We think about the new types of data being introduced. You think of IoT scenarios. The number of times I've heard something like, hey, I'm a mining company and I have wellheads that emit data. It just never occurred to me that some drill that's going 2 miles into the ground is emitting data. What do you do with that? You start to think of, what can I do with that? We think about mining companies. We think about, oil rigs. We think about all these things that you're not even, consciously thinking about. We all know about our cell phones emitting data. I mean, you're just walking around with a GPS device that's emitting data constantly. But all of these other things that are happening. There's a great story at Microsoft. It's called Building 88, the 88-acre project. And what it was Microsoft going through and essentially emitting all of this data from all of the environments in our buildings. They were trying to find out, our real estate facilities group was trying to find out, where are we wasting money in our buildings? And so they were able to look at some of these systems and figure out, based on building size, number of employees in the building, that kind of thing, here's kind of a common pattern about how much energy usage should be associated with each number of person in each type of building, so buildings that are similar. And in that story, they found that they had a single building that the data usage didn't seem to match the building size and the number of folks. They saw a specific spike in things like heating and air conditioning. They couldn't figure out what was going on. So they sent a tech out to the building. And they kind of wandered around the building a little bit until they found the sensor that was emitting the data. They found out that they had an air conditioning unit that had broken, and the vent was essentially heating an underground parking garage that was open air. If you've ever been to Redmond, it's basically like heating an ice box, right, constantly. And so they realized that by just having this simple sensor data that they could go look at and aggregate in these new kinds of data models that are being produced, they went off and shut the thing off, fixed the unit, and they saved them about $60,000 a month in heating costs in that building alone. And it's just because they had this new sets of data. Right? It's a new way of seeing the world and things that we aren't used to seeing. And then finally, obviously, all the new cloud-borne data. I mean, there's all kinds of systems online now that are emitting data everywhere. We talk about cell phones. We talk about things like social media accounts. I mean, the fire hose data coming out of things like Facebook and Twitter is phenomenally large for companies. I mean, the amount of data just being produced in social media today is just ridiculously huge. And so, but that has a lot of influence on the way companies are doing business. You often hear of companies that are taking not only their traditional sales data, marketing data, online feedback data, and they're munging that with their social sentiment data, whether that's likes on LinkedIn, whether that's how many page views I'm getting, or what kind of responses I get on Twitter based on viral marketing campaigns that they're trying. And they're munging that and trying to understand how does that relate to more sales. If I'm a retailer and I see a negative sentiment on a certain product in a certain region in the country, can I correlate that to a sales spike or a sales drop based on something? There's these canonical cases of people selling GMO foods, and they see a natural reaction, say, in Southern California, where there was a big campaign about non-GMO foods, and they see this correlation, and they're able to detect people talking about it on Twitter and a drop in their sales in that region, and be able to associate those data in ways that they never have before. So when Microsoft approaches this problem, they talk about it as the modern data warehouse. And it's really built on kind of that similar stack that you saw before. Microsoft's approach has been, traditionally kind of these two components in the last several years. You think about, kind of the relational data warehouses, so things like SQL Server or the APS appliance or the new SQL data warehouse service introduced in the cloud. And then you think about Hadoop as kind of that data management, that kind of core layer, that capture layer down at the bottom. Whether that's Hadoop running on premise, whether that's Hadoop in the appliance itself, and we'll talk about HD Insight in a bit, or whether that's Hadoop running in the cloud. But really having all these data sources kind of surfacing up in the appropriate place, and really being able to have it so that it's in a form and in a value that's appropriate for the business that's being run. And then obviously those data enrichment and BI and analytics layers built over the top. And so when we build these out, you really think about kind of what are the products, right? From Microsoft's perspective, there's kind of a core set of products that we're working from. Obviously, Office and Azure Cloud really offer, a capability of the BI and analytics at the top, things like, Power BI and the new Data Zen products, those kinds of things. And as we build down on the system, and in this talk specifically talking about kind of the bottom layer, really things like SQL Server 2016, the APS appliance, the SQL Data Warehouse, Azure HD Insight, and Hortonworks. We work very closely with Hortonworks. And I'll talk about kind of that integration here throughout this deck. So really when we talk about this, the APS doc, or the APS product is really kind of focused on solving some of these problems. When we think about kind of how a product is put together and how APS comes to market, it's really based on these kind of 4 tiers. The first is really this kind of legacy investment, really kind of trying to look at how do we, handle new data types, how do we build scale into systems that are unlocked or have been blocked previously by companies, limiting on the investment types of the hardware and the software packages that have been purchased in the past. Really, the second pillar is really talking about kind of big data solutions, whether that's both relational or non-relational data. So, not a lot of people want to stick their web logs in a SQL Server database. They change over time. Social sentiment data changes over time. So sticking that in a relational database traditionally means that you have to do a lot of work. As the schema changes of the data, or you have to build these complex schemas to support the different data types, you spend a lot of time just kind of chasing the changes that are in front of you. And it becomes very difficult. You're spending a lot of money and not getting a lot of value. Obviously, buying tier 1 hardware appliances, we talk about some of our competitors, and I'll talk specifically about them in this deck. We talk about the cost of kind of non-commodity hardware. When you talk about specialized hardware and how that impacts the cost of running a business and how it impacts the cost of running a large data warehouse, we really talk about kind of how do you commoditize that? How do you make the appliance itself very cost effective so that you're actually getting value out of the system, spending dollars that you get a return on that really truly impact the way that your business is run. And then finally, the ability to adapt kind of common business intelligence and making that work very seamlessly out of the box. So really putting kind of the entire package together. So when we talk about APS specifically, we call it the big data in the box. That's the term we use internally. We talk about it all the time. It's essentially a pre-built, pre-tuned appliance. It's a commodity set of servers that are worked with a couple of vendors, HP, Dell, and Quanta. And it comes from Microsoft as a completed unit. So you'll essentially buy the software from Microsoft and the associated hardware that goes with it, and it shows up as a rack. And it shows up at different scale, and we'll talk about the scale sizes. But it's pre-configured and pre-tuned, specifically for very large data warehouse workloads. The system itself is linearly scalable. It'll scale out to 6+ petabytes at this point, running over 60+ nodes in an MPP architecture. So how many people know the difference between SMP and MPP? It's okay if you don't. Okay. So the general kind of guidance I use, I've got 2 analogies. I'm going to use mine, and there's a colleague of mine who's sitting in the audience, and I'll use his, and we'll see which one works a little better. So the differences between the 2 kind of models is in the SMP world, you think of something like SQL Server, the box product itself. And really the model is it's a shared system. So you have shared bus, shared memory, shared operating system. And it really is kind of a combined constraint model. So you're going to have some roadblock in there that says, oh, I can't do something. I'm bound by some constraint, whatever that is. In an MPP system, it's a shared nothing model. Essentially, you just have high-speed interconnects, and each one of the cores or compute nodes within the system are completely self-contained. So they're not sharing anything, so they're not bottlenecked. And I always use this analogy. So imagine we're going to hammer 100 nails. You're a single person, and you just got a hammer. So I can hammer, right? And I can hammer them, boom, 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 and I'd be pretty quick at it. And I say, well, I want to make myself faster, so how do I do that? Well, I give myself a nail gun, right? Pop, 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 pop. That's another way to do it. Or if I really wanted to do this in the MPP world, I just give 100 people a hammer, and they each have to hammer 1 nail. Who's going to win? Right? Now let's amplify that. What if it's not 100? What if it's 1,000? What if it's 1,000,000? What if I could say, hey, each person only has to hammer 10 nails, and there's one guy who has to hammer 1,000,000 nails? Who's going to win? right? So this is kind of the core differences of an SMP and an MPP model. It's really kind of this divide and conquer model. So it follows similarly with other MPP systems. Things like Hadoop are built in the same model with kind of a controller, a management node, and a large set of compute nodes that are doing the divide and conquer work. So it's really built out that way. And I'm going to leave the beer analogy off because it talks a little bit more about skew and some other things. But I think you guys get the concept of what the differences between the two architectural models are and how MPP can be very efficient at very large scale. When we talk about things like clustered column indexing, so who has used CCI in SQL 14? Anybody? Ooh, one. I got one. Okay, so the concept of clustered column store indexing is really kind of a columnar-based indexing model. It was first introduced in APS about 2 years ago and tested at scale. And when we talk about scale, we have customers that talk about things in terms of single-digit number of terabytes all the way to single-digit petabytes. And being able to test in that environment is really something that we can take advantage of and prove things. When you're talking about a petabyte of data in an index, that's a much different model in testing things at much more extremes that can drive features back into things like SQL box products. So I'll talk about that. APS itself also has this concept of dedicated regions. So within a single appliance, you can have different types of data sets. So you can have a dedicated PDW, parallel data warehouse, relational data warehouse model. And then sitting next to it is a set of HD Insight nodes. You can actually run both of those different types of data set in a single appliance. They interconnect with common hardware, common interconnect, common networking, and you can really interact with both systems as a single appliance. And that's really this concept of kind of this relational and non-relational data kind of interaction with Polybase, and I'll talk about that. So when we talk about kind of APS delivering kind of enterprise-ready Hadoop with HD Insight, what this means is that we actually will ship a product where you can purchase the appliance that has both PDW and HD Insight. And that HD Insight layer is, like I said, connected between high-speed interconnect using InfiniBand networking. And it really means that as an individual appliance, you can have the best of both worlds. In some cases, there's truly a need to have Hadoop running in your environment. Things like weblogs are a great example of that. There's no reason to just take that and stick it into SQL Server for just kind of doing relational analysis. It's a pretty static format. You can land it in HD Insight as a data lake, and you can use that as just kind of a commodity store. But with something like Polybase, which I'll talk about in just a few minutes, it really gives you the ability to have access to that data in a way that makes sense. So who has, like I said, your shoulders are going to get tired, I apologize. Who's run a Hive job or a Pig job? Who knows what a Hive job or a Pig job is? A Scoop job, right? So these are technologies that people are having to learn. But when you go and sit in front of a customer that says, hey, look, I just have a bunch of data. I don't know how you do it. I just need a dashboard that tells me how many customers bought something and had negative kind of reaction to it on Twitter. Right? That end user doesn't care. They don't care that it's T-SQL. They don't care that it's a Java job that they had to write or a Python job or a Perl job or whatever it is front-end technology you're using. Giving access to that data in a way that makes sense to them when they're looking at just, give me a set of data that I can shove into Excel and do some pivots on. Right? How do you do that in a way where you have these kind of disparate worlds of data? So really kind of introducing this HD Insight region in the appliance gives you the capability of being able to shove that data into the system and then have access to it later via Polybase. It's truly, the Hortonworks data platform distribution that you see running in HD Insight in the cloud. It's the same versions as the cloud as those transition into be fully supported. When we release an APS release, we continue to invest in HD Insight being in the box. But as we talk about kind of Hadoop, right, Hadoop has had this kind of lately this kind of concept of it's the end-all be-all panacea. It's the new thing to solve your problem, right? I've been in technology for 15 years, almost 20 years at this point, and I've yet to see the end-all, be-all, one thing that solves every problem, right? Everything has its pros, everything has its cons. As you saw at the beginning of this deck, talking about the way that Microsoft is approaching the problem, it doesn't make sense for you to run search out of SQL Server. We have other tools and other capabilities that make much more sense to do that. So no longer are we giving you guidance that says run all of your stuff in SQL Server and try to run full text indexing. I mean, that's never been a product that's really been able to meet the needs. And so we've separated the two out and just said it makes sense to run it in a search service, so run it in a search service. The same thing with Hadoop. Hadoop has a set of advantages that make it a great product. We have no problem saying that Hadoop is something that is very useful in many places in your environment. But it doesn't mean that it solves every problem. Right? Spend some time trying to get Excel and Hadoop working together efficiently over time with things like integrated authentication from your Active Directory environment. And you'll spend a lot of time trying to get this to work. Try managing all of your inventory data that's in a structured SQL Server or Oracle-based data and sticking that in Hadoop and doing just relational queries across that. How do I join this without having to go through some complex kind of integration in Hadoop? And you realize that this becomes, an inefficient waste of time. You can do this in much better ways using things like just a SQL Server front end with Polybase. And so as we talk about Hadoop being, kind of not truly the answer, it has its place, as well as things like relational data warehouses have their place. And Microsoft is approaching the problem by saying the right thing to do is not to say, stick you in silo A or silo B. Use all the silos you have and integrate that data in a way that makes sense. And that's truly the approach that we've been taking. So when we talk about this, we really talk about kind of how we integrate all of these into a single system that you can take advantage of. So we start with things like data scientists. I love when Sean asks this question. Who has a data scientist in their environment? I see one hand, maybe two. Ooh, I got 3 or 4. Wow, that's actually more than usually is common. Most people don't have data scientists in their environment, yet the companies that do realize that those data scientists provide value. But it means that they typically have some kind of lower level knowledge of the systems, right? They typically have some background in programming, and they can take advantage of kind of advanced analytics models, whether those are predictive sales models, whether those are learning models around what customers might like to purchase along with something. We've all seen these shopping cart recommendations kinds of things. And they traditionally now want to work in Hadoop. There's a lot of tooling and infrastructure around that, so it makes sense for them to be there. But if we think about kind of traditional, director level, department level head kind of thing, they don't want to go into and learn Java, right? They know Excel. They know how to connect to a data source. They can simply pull the data they want and then munge it up in a PowerPoint, or they can munge it up, so that they can go show what the state of the business is, or they can connect it very quickly with things like SSRS or Power BI, and be able to put that data in a way that makes sense very quickly and easily. And so there's this kind of need for this additional use case. And then finally, kind of this new self-service BI model, where no longer is data locked in a silo managed by IT. The concept of moving to a data-centric, data-informed world is not only something that we see at Microsoft, we see everywhere. Internally, we are starting to do this quite often, and it means that everybody has access to all of the data in the systems at all the time. So how do you expose that data? Are you going to go through your environment and teach everybody Perl and Python to be able to run Hadoop? And that's generally not what people want to invest in. They want to invest in exposing the data in a way that makes sense. And so combining all of these different data sets is truly what we think about. The way we do this is through a technology called Polybase. This was written a couple years ago as a technology that really, inside of the APS appliance, gives you the ability to combine these two worlds. It was built in conjunction with the APS, the Analytics Platform System team, and the Gray Systems Lab, led by Dr. David DeWitt. So if you know Dr. DeWitt, he's kind of a technology giant in the data warehouse database world. And really, the two teams kind of collaborated on this concept of being able to interconnect the two and surfacing the data through simple T-SQL constructs. And this is truly done in the way that you would imagine. You essentially will create external connections out to Hadoop. You'll set up all of the kind of the file formats and things that you need. And then you can create external tables. And from a user's perspective, if you're familiar with T-SQL, it's literally select star from table. From an end user's perspective, it's no different. It looks like any other table that I have. But what it means is it gives you the power of all the T-SQL constructs, the front-end SQL Server access that you would get from all of your SQL Server tools, things that work with the APS appliance, reporting tools, loading tools, all those kinds of things. But it gives you access to Hadoop in that same familiar language. So it doesn't mean that an end user has to go learn something new. It means that you can just expose the data in a different way. But when we talk about how this actually interacts, you can imagine what the life cycle of a query is. So I'm doing a simple join. Let's pick two product categories. I have a products table, and I have a web logs table. And I've got some kind of correlation between the two. This is my URL, and the web logs are being stored in Hadoop, and I just see all the traffic coming out of my systems, and I'm landing it there as a data lake. And I've got my structured kind of product stuff, traditionally what you would see in inventory systems. These are the products I'm selling. These are what regions they're being sold in. And I want to do a simple join between the two tables. Using Polybase, it's simply select star from tables, inner join. Really simple, really easy. Anybody who's worked with T-SQL can understand that construct very quickly. But when the query runs, the interesting is what happens. So from a Polybase perspective, it's an additional, essential query engine that runs under the covers. It will make a decision based on statistics, which you can introduce over the top of your Hadoop data, as well as some topology information. So it's smart enough to understand, based on the statistics and the number of nodes running in HD Insight or Hadoop, and the number of nodes running in the appliance, it can make a decision, and based on all of those components, it can make a decision on what to do. And if it decides that the data is small enough and the interconnect between the nodes is fast enough, it'll just stream the data from Hadoop right into SQL Server, and it'll do the joins. It'll pull all of your data into a single place. But it may realize in the case of, we have a particular retailing customer, a very large national retailer here in the US, who's a very small appliance. It's a three-node appliance, so 3 compute nodes. And it's connecting to a 60-node external Hadoop cluster running Horton DataWorks. It's a big Linux environment. It's 60 nodes, something like 2.5 to 3 petabytes of data. In that environment, Polybase is smart enough to know streaming data out of there is not going to make sense. I mean, we could wait weeks or days for that to come back into the system. So it's smart enough to say, the thing to do here is not to just stream the data. It's going to generate a MapReduce or a yarn job. It's going to push that out into the Hadoop environment, let the processing occur in Hadoop, and stream the results back in for further processing, whether that's through joins or predicates. We can push down predicates through Polybase into Hadoop, allowing the customer to be able to take advantage of all the power they've invested in their Hadoop clusters, whether that's both in the appliance or external to the appliance in the case of this customer. But it really gives you that ability to have these connected islands of data come together in a single cohesive view of the data running. What this means, though, is as we build out the system, we take advantage and build some of the technologies that you're starting to see both in SQL Server the Box, APS, and some of the cloud services coming now. Traditionally, when we talk about performance that happens at data warehouses, you run into this kind of, we call it the forklift problem. As you want to make this system bigger, you got to go buy bigger hardware. I've hit the 1 terabyte mark. Okay, well, that doesn't run on my laptop anymore, so I got to go buy an enterprise class server. Hey, well, now I've got 100 users hitting it. Well, that doesn't work, so now I got to buy a bigger server. Well, I'm starting to run out of data. I'm going to shove some of my weblog data in there. Well, that doesn't work. Now I got to go buy a SAN, right? You can see this problem, and it continues to just get bigger and bigger and bigger, and you run into this problem of just forklifting. Every time you do that, you run into problems with, hey, I've got to migrate my data. I have downtime when I'm introducing these new systems. I still have reliability with every time we put new systems in place. There's always something that doesn't work. And so you get this kind of scale problem where you're spending more and more money to house more and more data, but you're getting a diminishing return because the results aren't coming back very quickly. You're in an SMP world versus MVP world. We also talk about things like row store. Like I said, clustered column store indexing was introduced with APS about 2 years ago to solve columnar data problems at scale. When we talk about doing joins across tables that have 1 trillion rows in them and doing that against traditional row index modeling, it really becomes a problem. It doesn't work in the way that you would think. So when we talk about APS, we talk about the way that it's introduced as a product. We really kind of have this concept of being able to scale. If you've ever seen one of these things, go into one of the HP or Dell booths here at the Expo Hall, you can go look and see a rack of servers. And imagine that just shows up at your site. It's pre-configured, and it looks like a single SQL Server instance. You connect to it, select version, select that at version, and it's just a single system. You run select star from table, and it runs across all those nodes. And it's actually fun to go kind of a hardware geek. You run select star, and you see all these things just light up because it's running a query across a bunch of nodes. But this can scale out across. So the system itself can scale out to 6 to 7 racks of servers. It can scale out to a little over 6 petabytes of data. Multiple nodes, hundreds of cores, terabytes of memory. These can be very large systems that look like an integrated, complete system. And when you add sort of this kind of forklifting model into how the appliance works, the appliance itself can scale. So as you add additional components into the system, it's not a forklift model where you're just traditionally taking the existing system, shutting it down, moving all of that to a bigger system. This is able to add this concept of a scale unit. You see these kind of blocked out here as a PDW HD Insight region, where you can just add additional compute infrastructure into the environment and just make it bigger and get larger in scale. It also means that you can scale these out independently. As the 2 different regions, if you need more of a compute horsepower or storage horsepower in the PDW side, the relational side, you can go ahead and add that. Likewise, you can also do that in the HD Insight size. So if you have that traditional customer, you have a small set of nodes for relational and a large set of, say, Hadoop data, whether that's relational data that you're pulling out of things like your existing systems that you're landing in your data lake for whatever reason, or whether they're things like social sentiment data, you can scale those independently. And it allows you to scale each one of those up to 6 racks. So you can imagine the largest systems being something like 6 or 7 racks of each side. So you have a 12-rack system that looks like one giant SQL Server. Imagine the power when you get to those massive scales. And then all of this introduces kind of this concept of the blazing path fast performance that you see. So with some of the advantages that we've introduced with SQL Server itself, things like clustered column store indexing, and the addition of the MPP architecture thrown over the top, we get this kind of concept of parallel query execution. If you kind of watch the bottom here, what you're going to see is really the process that a query travels through the system. We have what we call a head node, which is traditionally, or we call it a control node, which is essentially just the kind of the monitoring and management. This is where a distributed query plan is created. It's executed against all of the individual nodes in parallel, and the data is aggregated and results are returned back to you. By taking advantage of these, you see all kinds of advantages at scale. From a query performance, just cluster column store indexing, some of the in-memory technologies that have been introduced in SQL Server, you can see queries that literally can go from days to minutes to seconds. I was involved with a particular customer who had a very large data set. Their entire data warehouse was about 14 terabytes, and they had a query that would run for 7 days on a SQL Server system. With no modifications of the code, we were able to lift that data, put it into just a half-rack appliance, 4 nodes, and it went from 7 days execution time to 37 minutes. A massive amount of performance improvement without any tweaking. After spending about a day kind of modifying the way they actually executed their query to take advantage of kind of scale and this model of kind of parallel environments, we were able to take that query that took a little over 7 days to 37 minutes to a minute and a half. And the customer was able to realize that they could see what was going on in their business every minute by clicking a button. Let me run the query. Let's see what's happening now. Where they would have to wait a week to find out what happened in my stores today. Well, I won't know till next week. And that caused them a big disadvantage when they were going out fighting their competitors. So it gave them the opportunity to be able to do things that they were no longer, or that they were unable to do before, just because they were bound by the limitations of the systems they were using. And we think about things like compression. Generally, when we talk about just simple things like clustered column store compression, across the industry, not just Microsoft, we talk about kind of this 5 to 15x compression range, where you take data that's sitting on disk, you throw it into this columnar format, and we're able to compress the data pretty quickly. I've seen anywhere from 5 to 300% compression for customers. So really think about all of this data being compressed into small formats. And SQL Server can then take very big advantage of all this data in a way that makes sense to it. And we can have very optimized query plans that can run at massive scale very fast. And you'd be amazed when we talk about results going from days to minutes to seconds. And this is the reality of running a system like this. So here's the million-dollar question. Why would I move out of SQL Server? We make big announcements, at conferences like this about things like SQL Server 26 and integration with Windows Server that has 12 terabytes of RAM and a lot of the things that I would do in making those systems fast. Why wouldn't I not just pin all this all this data into memory? Why would I not just use SQL Server? And there are really valid use cases for why you wouldn't do that. The first one is this kind of just the simple model of the architectures. Really running SMP, you'll run into some of the core limitations that you're bound by. Bus speeds, shared memory, shared computes. And you can scale those out, right? There's very large systems. If you're able to see Lindsay Allen's session talking about Superdome, for example, they're able to scale out the systems very large and be able to produce kind of concepts of making SQL Server fast. But even at the largest scale systems, a simple commodity SMP system, a very large SMP system running against a commodity MPP system, the MPP system can outrun it every day of the week. And again, it comes back to that analogy I was giving you. I don't care what kind of nail gun you have and how fast that thing works. If I gave 1,000 people one hammer and they all have to hit one nail, it'll outrun any nail gun you can produce in the world. It just will. And you use that concept kind of to think about just the two different architectures. A lot of times they're just built for different things. When we talk about kind of the integration, when we talk about the way that you scale something like SQL Server or some of these other products, you really start to talk about, well, you run into different things. Disk I/O is common problems in trying to get these systems up with very large amounts of data. We just cross over those terabyte ranges, you start to run into disk latency issues that cause these systems to fail or not perform at the levels that you're expecting because you run into common bus problems of moving data from that into the CPUs. When we talk about the appliance, we have large disk arrays that are then not shared across all of these infrastructures. So not all of the cores are fighting each one of their peers in order to get access to the data. We talk about linear scale. We talk about performance tuning over SMP systems that really kind of make the system just out of the box work at a very high performance level with very little tuning. And then finally, obviously, making sure that you still have that seamless integration. So all the things that you would expect to work in SQL Server just work. You can connect your BI tools to it. You can connect your load tools to it. So you have all the advantages of SQL Server with the performance that you would expect. And then finally kind of talking about how we engineer this. So this is kind of a pivot on the way that we talk about the appliance. So there have been studies done across all of the vendors. They were done by independent third parties. I'm a Microsoft employee, so obviously my bias is to present Microsoft in its best light. But these were done by independent vendors, and they've gone out and they've studied how much it costs to actually implement a data warehouse based on one of these appliance models. And you can see some of them here. Microsoft has lowered our costs by doing a couple different things. We've taken advantage of some of the technologies available to us. So we talk about Windows Server and some of the things like storage spaces. So we can lower the cost of running one of these appliances by not having to have dedicated hardware to do things like storage management. So we're able to take advantage of things like storage spaces to be able to control all the data running through the system. We've also been able to take advantage of some of the other things that are going on in the system, whether that's advantages in SQL Server, whether that's advantages in hardware commodity prices, because the appliance itself is built on this concept of core commodity hardware. We don't run anything custom that you can't just go online, pick on one of the vendors, and pick out the servers themselves. It's actually fairly commodity hardware. It's mid-level, not high-end level hardware, and we're able to take advantage of this MPP architecture to be able to scale well beyond what $1 million, $2 million SQL Server systems could do with these large sandbox systems. And by taking advantage of those two components, commodity-based storage and MPP architecture with all the advances in SQL Server and Windows Server, we're able to scale these systems very quickly, very large, and do it very cost-effectively, better than anybody in the industry. So really, as we talk through kind of what this system is, it's really kind of value through kind of the single flexible appliance solution. It gives you all the advantages that you would expect. Talking about things that most people don't really think about when they're talking about building systems out. Reducing data center footprints, reducing energy costs, reducing heating and cooling and management costs. The appliance itself is sold as a white glove service, so there's a dedicated support engineer who manages the infrastructure for you. So things like upgrades. So whenever there's an upgrade to the system, it's actually managed by Microsoft. We'll come on site, we'll upgrade the appliance. We're a frontline support for any hardware issues. So if you have any issues, you have a single point of contact for all of those kinds of things. And it really gives you the ability to scale out the system to meet whatever needs you have. So it's a system that grows with you over time. It's not something that you buy once and think, oh, this is only going to last 18 months. I hope in 18 months it's not going to be that big a deal for my business to be down for a week as I move to a new system. We have, kind of all the things that you would expect from a Microsoft system, management through System Center. There's a management pack available for the appliance, so you can monitor what's going on in the system. There's all kinds of things like integrated authentication, so you can use your existing authentication environments, whether that's Active Directory, and use that to manage the appliance, so you have complete control over the way this works. It follows the way that you run your business, not introducing new concepts to make it easy. And then finally, kind of reducing tuning. So as we talk about the tuning models, some of this is based on the hardware that's been set and the definition of the way the hardware's been put together so that the system works efficiently together. So you have processors and cores and storage that all work efficiently together with all kinds of redundancy built in, giving you the capability of knowing that the system's going to be highly available and be able to meet all of your needs without having to put in a lot of effort of managing and maintaining the system. And so what this looks like. So when we talk about kind of these vendors and what we do with them, it's truly kind of this co-engineered. It's one of the first times I've been involved in my 11 years at Microsoft and really seeing this real partnership that comes across between Microsoft and its vendors in delivering a solution. We have an open communication both ways where we're talking about new hardware advances, some of the new servers that are coming out specifically, say, from Dell and HP, and how we introduce those into an appliance and take advantage of the capabilities there, whether that's in a reduction in cost because we can run the same amount of horsepower at lower cost, or whether that's by taking advantage of some of the new capabilities in those services that we can light up through things like Windows Server. These are obviously pre-configured and pre-built. You don't have to worry about things like firmware updates or driver updates. It's all managed through the APS model. So it's a completely self-contained environment that allows you to be able to move between what the system is doing and how you manage it and worrying about focusing on getting insights out of your data instead of worrying about actually running the system. And then finally, obviously, coming back to that commodity hardware model. So really building out on core commodity hardware. Again, there's nothing special here. We run JBOD storage, we run standard commodity middle class servers to give you the capabilities of the things that you're expecting the system to do, but not, again, charging a very large price for doing it. So finally, I figured I'd show you a little bit about kind of what the system looks like. So when we talk about what scale looks like, we talk about these and I just pulled the HP chart here so you can take a look at these. We talk about these things in scale of racks. So we talk about things in quarter racks and half racks and one racks. And what does that actually mean? So when we talk about this, we talk about these in these core concepts. We have this concept of a base unit, an active unit, and a compute unit. And I'll explain what all these are so you can kind of follow along very quickly. A core base unit and an active unit really means that we have this concept of redundancy built into the system. So when we talk about things like active compute nodes versus spare spaces, we use things like Windows clustering to make sure that if the virtualized layer that's running all of this infrastructure, if something goes down, a hardware failure, we're able to fail over in different environments to make sure that the system's highly available. When we talk about the number of compute nodes, these are the actual things that are processing. So when we talk about something like a quarter rack, this is really just a 2-node system. So it's 2 kind of commodity servers running as a single system. And as this scales up, you can see, we can get up to 56. In this case, HP is 56. Dell's a little bit higher in the number of nodes that we can condense into a rack. But you can see the amount of capacity increase from the level before it. So as you were talking about, the number of racks and the number of spaces that we use, and the power that comes with that. So when we start to talk about things like disk capacity, right? At the very smallest scale, we're talking about, a quarter of a petabyte of storage in our smallest scale unit. Being able to just grow in your environment at that scale. And as your data throughput increases, as you start to realize the advantage of running something like an APS appliance, you can see that this thing can grow up to massive scale, all the way up to 6+ petabytes in size, giving you the capabilities to have the system grow with you. Oops. So with that being said, I'm going to leave you with these kind of 4 pillars. The APS system itself is kind of a no-compromise modern data warehouse. Again, it's built on these kind of 4 concepts. Being able to meet today's kind of big data analytics problems, doing that in a way that makes it price performant for you, running it as an online business so you don't have to worry about all the commodity problems that you traditionally deal with the data warehouse. Managing and maintaining the hardware, managing upgrades, taking care of all those kind of just core things, and then having all of the data flow all the way through your system, all the way up the stack, from storage through analytics and all the way to visualization and BI. It's obviously working with Hadoop and HD Insight, both in the appliance as well as Horton Data Warehouse, Cloudera as external Hadoop clusters, whether those are on-premise or in the cloud, through Polybase, and giving you kind of this enterprise-ready data view of the world that you have based on all of the different systems that you're running, whether that's traditional structured or now new non-traditional unstructured data. And talking about performance at scale. So when we talk about these systems, we really talk about things, and I know I asked the questions to start with, and I've been talking about hundreds of terabytes or tens of terabytes. These are real numbers that when you start to think about how you can run your business in a different way, what happens if you had access to that data immediately? Could you make a better business decision when a competitor does something, you want to go analyze, what does that do to my system and what does that do to my business? If a competitor puts, say, a 20% discount on, can I go match that? And how would that impact my demand forecast? And what would that do to my margins? Can I model that? Can I do that efficiently? Instead of taking days, weeks, or months, can I do that now, on demand, real time, and model all the time, enable me to make business decisions based on data that I already have in my system that's blocked? And then finally, doing all of this in a way that is cost effective. Microsoft has always come at the approach that it's great if we want to build these Superdome systems with very large sets, but really trying to approach this problem saying, this is something that every company can get into. We talk about the way that we efficiently use both the software and the hardware in a way that makes you get into these systems very easily, but still have access to all of the power that you would expect at something, a very large enterprise system. With that said, if you want to learn more about Microsoft APS, you can go online to the APS site. It has some more details about all of kind of what we've talked about here. And I appreciate your time this morning. If you have any questions, I'll take questions now. If not, enjoy the rest of your day here at Ignite. Thank you, everyone.